So what we want to do here is identify like terms and combine them together. So this is another part of simplifying expressions, is we have things that are similar, we can combine them together. Instead of two separated terms, they could be combined into a single term. So what makes two terms like or similar? What they need to have are the exact same variable factors. So that means same variables, same exponents on them, exactly identical. So, for example, these are similar terms because they both have x, and for both of them, x has the power of 1. So those are like terms right there. Here, also like terms. Really, I'm just focused on the variable part. The numerical coefficient can be whatever it wants to be. What I want to notice here is that they both have m, and the power of m is the same. These are two constants. We can absolutely combine those together. We're quite used to that scenario. But the idea is that they both don't have variables, and that makes them similar or like. And then this last one I really like as an example because it really shows you how much it needs to match up. So they both have x, they both have y as well, and then x has the same exponent, y has the same exponent. That makes these like. If we had, let's say, 2x squared y cubed, and we had negative 5x squared, and that was it, not like, because we would be missing that y cubed portion. So those are not similar terms. Let's say they both had x and y, but x was cubed and y was squared. Those are also not similar, not like, because the exponents aren't matching up. Those would both need to be 2's, those would both need to be 3's. So that's the way they could differ, but when they differ, they're not like. So what we need is this kind of perfect matching up of the two. Okay, when we combine like terms, what we're going to do is add or subtract the coefficients, and we keep the variable factor the same. So 3x plus 5x. So we're going to combine those together. And what this looks like is we're going to combine the numerical coefficients, and we're keeping our variable factor the same. So because x is our similar portion of it, our similar variable factor, that stays. But then what we're going to be doing is 3 plus 5 for our numerical part. So 3 plus 5 is 8. So this simplifies to 8x. But notice x does not change here. We want to make sure that's true whenever we add and subtract and we're combining like terms. That's true. What I often use as an example here is like, this is a scenario where it's like we have 3 apples and we're adding on 5 apples. So at the end of it, we have 8 apples. So apples, they don't change form in any way. They're still just apples. But what it's doing is that we, instead of having 3 apples separated from 5 apples, we can just combine them all together as 8 apples. All right, let's go through some more examples here. So with this scenario where we have x and x squared and then x again, first thing we want to do is recognize what are the like terms. So this 3x and minus x, we can combine those together. This x squared is something completely different. So it's like we have 3 apples, and then we have an orange, and then we're taking away an apple. So things are happening with apples, then this orange is just kind of hanging out there, and it's on its own, and it can't combine really because it's different. So what we're going to do here is we're going to combine the things that have x involved, and then that x squared is just going to stay adding on because it has nothing to combine with. So what can help for seeing numerically what's happening here is that we have this 3 and then we're subtracting 1. So the numerical coefficient for x now is a 3 minus 1. So we're going to have 2 of those x's plus x squared. Now, if you wrote this as having the x squared first, let's do this another way. What we could have done is had x squared out front and then adding on, and then seeing what's happening with x and having the 3 minus 1 in there. So getting an x squared plus 2x. exactly the same thing. That's a property that we'll talk about more when we get to real numbers and their properties, but it's the fact that with addition we can switch it around. So 2x plus x squared is the same thing as x squared plus 2x. So order doesn't matter too much here. At a certain point, when we get to things called quadratics, we like to have this form where the degrees are decreasing as we go across the expressions, like degree 2, degree 1, but they are the same thing, so you don't need to worry about that too much. Okay, a few more examples here. 18xy minus 12xy. So first thing I want to make sure is that they're like terms. So we have x and y, and then the exponents are matching up. So perfect. I can combine these together to have a single numerical coefficient, and then we're just going to keep that xy out there. So we're going to combine the numbers. So 18 minus 12. So that means we're going to be left with 6 of these xy things. All right, one last example here. Okay, so this one we want to be careful because everything has x and y, but we can only combine the ones that have the same exact exponents. So here we have x and here we have x, but x is squared here, x is not squared there. So we have this thing and then this different thing, and then this last one we have x with an exponent of 1 and y is also squared, so that matches up. So we have these like terms that we can combine with each other. So that negative 2x squared y is just going to stay the way it is, but the xy squared we can combine together. So combine the xy squared values, and we're going to have a 5 plus 3. So again, I'm just grabbing the numerical part. So 5 and the plus 3. And then we have this minus 2x squared y just staying out on its own because it has nothing to combine with. So 5 plus 3 is 8. So that's our new numerical coefficient, xy squared minus 2x squared y. And that's our combining like terms. So first thing you want to do is identify the like terms, and then you combine them by adding or subtracting their numerical coefficients together.